Hello everybody, welcome back to my channel. Today's video will be quickly covering the topic of glucose sensors. This comes in the topic of medical application of how chemical sensors are used in medical application or medical diagnosis. So let's begin with glucose sensors. Now, why do we need glucose sensors? Glucose sensors are used to measure the amount of blood glucose level present in the blood or in the interstitial fluid. This, for example, these are of two types. This is first biochemical reaction happens, and that biochemical reaction is converted into electrical signal, which is sent to the digital meter, and then we get a glucose reading. Basic principle, even if in case of the glucose meter. Okay, anyway, I'll just tell you. There's two types of glucose sensors. One is blood glucose meter. I just write it. Blood glucose meter. Other one is continuous glucose monitor. Both of the working principle is very similar. I'll just tell you. In blood glucose meter, what happens is a strip is given, a disposable strip which has some enzyme. I'll tell you about the enzyme in a while. This enzyme, we put a small drop of a blood, right? We put a small drop of a blood. Now the glucose in our blood reacts with this enzyme. The glucose in our blood reacts with this enzyme, and it produces a small current. I'll tell you how it happens. I'm just briefing you out here. The current produced is proportional to the amount of glucose which is present in our body. That current is sent to the digital meter here. That will convert the current into digital glucose readings, which we can monitor. It comes in a fraction of seconds. It comes. Okay. Coming to this is I'll tell you. Coming to continuous glucose monitor, what is happening here is we use a small probe-like structure. That probe is attached to the interstitial fluid, not to the bulb, and this is entirely placed in the abdomen or it can be placed in the arms also. Arms or abdomen. Now this is a probe. This is connected to the this is basically glucose sensor itself. Probe, interstitial fluid. Here the same working principle only. This is connected to the transmitter here. The transmitter sends signals to the phone or smartwatch wirelessly. Okay, that was it. Now I'll explain you in detail. So blood glucose monitor, what did I say? Small drop of blood placed on the disposable test strip. Strip contains enzyme. The glucose in the blood reacts with the strip. Current is produced. The amount of current generates depends on the glucose concentration. Digital meter shows the blood glucose level within a few seconds. Continuous glucose meter, what did I say? A probe is there. Tiny sensor probe. The sensor is just below the skin in the interstitial fluid, which can be placed in the arm or the abdomen. Now a transmitter is attached on top of the probe. So what does this do? It wirelessly sends the readings to the receiver or smartphone or smartwatch. So this helps in continuous track of the glucose level without any finger prick. Now coming to the working principle, starting with the first biochemical reaction. There are basically two types of enzymes. Okay, first one is glucose oxidase. This can be represented as GOX. The next one is glucose dehydrogenase. This is GDH. So now what happens is when the blood falls on the strip, right? That enzymes I told you two are there. These are the two not two enzymes is there, only one enzyme is there. This or that. Okay, that is the enzyme which is present on the strip. So the glucose in the blood reacts with these enzymes. So what happens? Glucose plus oxygen in the presence of anyone, say glucose oxidase, it forms gluconic acid and H2O2. What is H2O2? Hydrogen peroxide. So what did I say? When the glucose in the blood reacts with any of the two enzymes, it forms gluconic acid and H2O2 hydrogen peroxide. Next comes the electrochemical reaction or detection part. Here what happens is that the H2O2 will undergo oxidation in one of the electrochemical cell. It will form 2H plus, 2 electrons and O2. This will generate detectable or measurable amount of current. Measurable amount of current is generated. The amount of current is directly proportional to the concentration of glucose in blood. So if more glucose concentration is there in your blood, then current generated will be more. If the concentration of glucose is less in your blood, then less current will be generated. Then what happens? This current is then sent to the third step is that digital processing. Signal processing. Signal processing. Signal processing. Here what happens? The current which is generated, that is sent for processing to the microprocessor. The microprocessor will convert the current into digital glucose reading, which is displayed on the device. This is in case of blood glucose meter. Now in case of continuous glucose monitor, till here this thing is the same. Okay, just a signal processing part. What happens? The probe has a transmitter. This transmitter will send signals wirelessly to the receiver. The receiver can be phone, smartwatch, all of that. Okay, now I'll just tell you how this works. This is the interstitial fluid. This is the skin. This a probe is attached here. Basically this is a sensor, and say this is the probe which is like inserted. This has the transmitter, so it will measure the glucose level and send signals wirelessly to the receiver. That's how it works. Now coming to the advantages. So advantages, let's talk one by one. First let's talk about blood glucose meter. This is, first of all, it is fast, it is accurate, and it is portable also. Easy to carry, right? Then very small quantity, that is just 1 drop of blood is sufficient. Next, coming to continuous glucose sensor or monitor. Here no need of frequent finger pricks at all. Then this is trend based analysis, because you connect it with the whole day or for a long period of time. Every 5 minutes, 10 minutes, or every frequent amount of time, it continuously keeps measuring. So then what happens? Smart diagnosis of insulin. Basically smart insulin dosing decisions. These were the advantages, and this was the basic working principle. If you want, I'll just repeat. So sensor has enzyme glucose oxidase, glucose dehydrogenase. When the glucose in the blood reacts with the enzyme, gluconic acid and H2O2 is produced. H2O2 goes to the electrode and oxidation takes place. This produces an electrical current. If more glucose and more current, less glucose means less current, means directly proportional to the concentration of glucose in the blood. The electric signal is then processed by microprocessor, which converts into current into digital glucose reading. And in CGM, what happens? The transmitter sends these readings wirelessly to a smartphone or receiver. Advantages is what? It is fast, portable, accurate, requires only small drop of blood. Here no need of fingerprints. It's a trend based analysis, shows glucose trends and variation, and also this is continuous monitoring. That is the advantage. Based on that only we are going to do trend based analysis and smart insulin dosing decisions. So that was about it. Thank you for watching. I hope it helped, and I hope I have covered it all. See you in the next one. Bye bye.